This is the fourth video for chain rule applications. It's the first one for applications. The first three dealt with the algebra of the chain rule, and this video has to do with applying the chain rule. So the first problem is find the tangent to the curve of y equals 2 tangent pi x over 4 at x equals 1. So the first thing I think of is when it says tangent to the curve is I want to write the tangent line formula. So that's going to be y minus y1 equals mx minus x1, and this is the point slope form. So if you look at it, I need a slope and I need a point, and the point right now is 1 something. How do I find the something? Well, I have to put the 1 into the formula to find out. So I have y equals 2 tan pi times 1 over 4. So it's y equals 2 tan pi over 4. And I know that the tan of pi over 4 is 1. So 2 times 1 is 2. So the point 1, 2 is on the graph. So I'm going to eventually put the 2 here and the 1 here. So I've got the point that it's going to be at. But now I've got to figure out the slope. Well, the slope is going to be the derivative of this. So I'm going to do y prime. Okay? So if I do the derivative, it's going to be 2 times, and the derivative of tan is secant squared. Okay, don't touch the baby, so I'm going to leave this alone. Then we have to do times the derivative of the inside, and you can really write this, if you will, is as pi over 4x, because this is a constant, this is a constant, so you can put it in the front x, and so I would do the power rule on this, and it would be times pi over 4. So when I go to do this, I want to do y prime of 1 because I want to know what the slope is at 1, so I can put that in my formula. I do 2 secant squared, and if I put a 1 in here, it's going to just be pi over 4 times pi over 4, which equals 2 times, and the secant of pi over 4 is going to be, if you think about it, it's going to be the same as 1 over the cosine, and cosine of pi over 4 is radical 2 over 2. So we're basically going to flip that, 2 over radical 2 squared times pi over 4, which equals 2 times 4 over 2 times pi over 4. And you'll see this cancels here for a 1, this cancels here for a 1. So the whole thing, the slope comes out to be pi at 1. So if I put this in my formula here, so I'm just going to kind of write this down here. So my tangent line is going to be y minus 2. That's the y value of my point that we found before. And then equals the slope, and the slope is pi times x minus 1. So our equation of the tangent line is going to be pi x minus 1 plus 2. And we can actually multiply that through if you needed to, but that's good enough for me. I will take that for the equation of the tangent line at that point. So you've done something like this before, but just the difference now is now we're doing the chain rule, and so you have to do the derivative of the inside. Alright, here's another position of a particle moving along a coordinate line. Sorry, it's kind of overlapped. So it's S equals, just so we can see a little better, 1 plus 4t, radical 1 plus 4t. And it says where S is in meters, so I'm going to label the crap out of it. This is in meters, and t is in seconds. It says find the particle's velocity and acceleration at t equals 6 seconds. Okay, so let's get started. If I do the velocity is the derivative of the position. And to make a little bit life easier for this derivative, I'm going to actually rewrite this as 1 plus 4t raised to the half. Then when you see this, you can do the power rule first. So the derivative is going to be 1/2, don't touch anything in the parentheses, raised to the negative 1/2. Then the derivative of the inside right here is going to be, this is 0, and the derivative of 4t is 4 times 4. So 4 times a half is 2, so I end up with 2, 1 plus 4t to the negative 1/2. okay? Or we can write it like this. Or you could write it as a square root. So right here is the velocity, okay? Now if I want to know the velocity at 6, so let's plug that in. So I have the velocity at 6 is going to be 2 over 1 plus 4 times 6 raised to the half, which comes out to be 2 over the square root of 25, or it's going to be 2/5. And my pen's writing weird, so I apologize for that. So that's going to be 2 over 5, and then I have to do the units, so it's going to be meters per second. So, sorry it looks weird, but it's 2/5 meters per second. Now it wants us to do the acceleration, okay? Well, the acceleration is a derivative of the velocity, okay? So I have to do the derivative of the velocity. Well, right here is the velocity. So I could do the quotient rule or the product rule, whatever you want to do. And if we did the, I personally probably would do right here is do that, because then you do the power rule. So if I take the negative half times 2, that's going to be negative 1. Don't touch what's inside. Wow, this is really writing awful. I'm so sorry. Let's finish this up here. It's one problem, and then I'll just start it. So I've got negative 1 times, and it's going to be 1 plus 4t raised to the negative 3/2. There, that's a little bit better. Times the derivative of the inside, which is be 4. So it's going to be negative 4 times 1 plus 4t raised to the negative 3/2. Okay, so if I want to do the acceleration of 6 seconds, what it would be there, I say the acceleration at 6 seconds is going to be negative 4, 1 plus 4 times 6 raised to the negative 3/2, or it's going to be negative 4 over 125, and it's going to be meters per second squared. So there's two problems where I use the chain rule to come up with the answers for a velocity and acceleration. Okay? I'm going to do another video with a couple other problems, but this one is good for now.